Okay, we're going to do the last two problems on your note sheet. So again, we draw a line down the center from the top to bottom. We draw a line across from side to side. So remember, we need to find C. So C is the value from this focal point to the center. That value, if you measure it, is about 2.5. Now we need to find the value of A. A, you measure from the center to the end of the ellipse. And that's about 3.5 when you do it on your paper. So eccentricity is C, which we already measured was 2.5, divided by A, which is 3.5. Then once you divide those out, this gives you a value of about 0.71. That is our eccentricity for this ellipse, or for this orbit, which means it's close to being elliptical. All right, and our last one. Let me zoom out a little bit here. All right, so our last one, you're going to draw a line from the top down to the bottom. Remember, use a ruler so your lines are straight, and a line across the center. So we want to find C. Our C value is from this first focal point to the center. So C is about 0.8. For our A value, when you measure it, and we are measuring these in centimeters, I just don't have enough room to write this down with centimeters. You are going to measure from the center all the way out to the edge, and that is about 5.5. So in order to find your eccentricity, we're going to take C, which is 0.8, divided by 5.5. Once we divide those out, our eccentricity for this is about 0.09. That means this is very, very, very close to a circle because it is closer, very, very close to 0. It's the closest to 0 except for the first one, which was 0. So remember, all of these are measured in centimeters. You also need to make sure you're using a ruler when you do this. Some of your values may be a little bit off for mine, but that's okay because that just matters where you have drawn your lines. But these are your examples for how to find eccentricity and how to determine if the orbit is more circular or elliptical.